3, we're going to find the following of this thing. We're going from 1 to 5. Now we have being multiplied to f of x. We're adding 4. We found that the whole area of this thing, okay, not the function, but the function multiplied by 3, then added, so this thing then scaled by 3 and then lifted by 4. So the area is bigger than actually what f(x) really is. So the whole area of this bigger function is 34. What is actually the area of just the function itself? After we got rid of the multiple here and we got rid of this addition here. Okay, so paying the parentheses here, it looks like the 3 is just f of x. So I'm going to start this. I'm going to rewrite this as a constant, okay, of f of x dx. All right. Then 4 plus, that's 5 of 4. So we're going to both instances, but see that design means that I have two different areas being, all right. This one is because it's being all 3, but this one is just 4. So I'm going over the same area. It's just that split. All right. And so I actually want to solve for this right here, okay? Because I know this whole thing equals 34, right? But I want to know what this guy isolated is. So if we were to just for a second imagine this plus 4 equals 34, just look at it for a second. That's really what we're after here, right? Now, okay, just ish. The idea is that block equals something else, right? Because we want to know that area, and we have a formula for that, and we're going to plug in right here. So this guy, really, I shouldn't have wrote a 4. I should have some kind of block there. But 3, I don't know what this is. Plus this block here has to equal 34. Okay, so let's figure out what that block is. So I've got 3. The integral 1 to 5 of f of x with respect to x. Okay, now the formula said k times b minus a. So k is actually 4, and b is 5, and a is 1. So this means that I have 3x plus 16 equals 34. So really over here, what I should have wrote is 16. So this is 3x plus 16 equals 34. Believe it or not, to the 8th grade, right? Because this whole thing is an area that we don't know, but we know multiply by 3, we added 16, we're going to get 34. So what I'm going to do is I'm going to subtract 16 from both sides. Okay, I get 2, 1, that's going to be 8, and then that's 2, and then that's 3. So it looks like it actually equals 28 divided by 3. All right, and that's all that really 20. Whoa, did I screw that up? Okay. Let's say 2 minus 1 is actually 1. And that would be 18 divided by 3, which is actually 6. Okay. Ooh, okay. It is rather late. However, that should not have happened. There. Here we go. even and odd functions. Now this is kind of here. Here's actually the great of why you actually learn even and odd functions. Why we spent a few days, testing and quizzing on it, and it's just so much easier when you get to calculus if you understand even and odd functions. This was right here. Think of it. If I have an even function, and I'm not doing that right now, I'm not even going to look at it. But if I have an even function, and an even function is symmetric to the y-axis. If I wanted this total area, can you see that I really have two identical areas? I can go, I can just do from here to here and multiply by 2. That's it, right? I can go from here to here and multiply by 2. Sometimes functions are hard enough to integrate. If I know that I have an even function and it's symmetric to the y-axis, I just do this piece and I just multiply, I double it. And then that way I don't have to actually have this long integration that can be actually very complicated, as you will see in a few lessons down the road, that it is so much better to go rather than going from -4 to 4. It just is. All right, and trust me on this. If you know it's even, all you have to remember is that this guy is actually double. Okay, let's say that I'm going from 3, and this connection, if I'm going from 0 to 3 here, and it's 8, okay, from -3 to 3. Well, if 0 to 3 is 8, and it's even, then that means it's got to be 16, right? Well, what if it's odd? What we alluded to before. Now, the ideal odd function is, y equals x to the third power. If I want to go from 0 to 3, that area there, I don't know what it is. But if I have the odd function, if it's negative and this is positive, can you see how they cancel each other out? Okay. If you know that this is an odd function, and you're like, is there a shortcut to this? Because this is really complicated. Is there a way that I can kind of add the areas appropriately? If you know it's specifically an odd function, then it's great, because it's not all odds are going to equal to 0. But what I'm saying is you kind of understand you have the symmetry, right? So if I went from -3 to 3, it's got to be 0. Okay, so that's the whole point of symmetry. Even if you never use this in your life, think about mentally patterns, right? Think about patterns, and if your brain can absorb and understand patterns, apply to many different kinds of geometries and situations. Okay, so even and odd functions are pretty important to help you when we deal with today. All right, so I'm actually going to stop here, and I'm going to put example 5 in, right? That will be 4 of 4. Au revoir.